In this video, I'll be doing a detailed solution to the maths question you see on the screen here from the Cambridge A-Level Mechanics paper 4.3 from 2024. If you're looking for a different question from this paper or a different paper entirely, check out the description below. And if you find this or any of the other videos on my channel useful and would like to help me out, the best thing you can do is share it with other people doing the exam. Perhaps if you're in a class WhatsApp group, share it there. Failing that, a like, subscribe, or even a super thanks. In question 6, we're told about a cyclist and their bicycle that weigh 80 kilos. They're traveling along a road and they tell us some resistance force. Let's start drawing some of this. So here's the cyclist. We'll just, as always, just a ball is fine. So we'll say they're going this way. They're pushing forward with some force. And they tell us, or they ask us about the power output of that cyclist. They give us a force of the resistance against them. But we put this number as 32. We will say there is some driving force forward, and that is related to the power they are asking us about. They're asking us about power, they've given us some force. So let's remember there's a formula for power and force. Power is velocity, isn't it? Yeah. Power is equal to force times velocity. And they've given us a velocity. They say at the instant when she's traveling 7 meters per second and her acceleration is 0.1, they want to know about this power output. So using all that, first of all, we can add these two forces together. We don't even know this one, but we can do it because they told us the overall acceleration is 0.1. They've told us the mass. So we know the overall force. These two added together must be equal to MA, which is equal to 80 times 0.1, which is equal to 8. So D take away 32 is equal to 8. D must be, this driving force must be 40. That's not an answer. They want to know the power output. Remember, power is equal to the force times the velocity. Force is 40 and the velocity was 7. So that equals 280 watts. That's the answer to part A. In part B, they asked to find the steady speed. Now, steady speed, I'm already thinking acceleration is 0. So the steady speed the cyclist can maintain if our power output and the resistant force are both unchanged. Okay, so she has this power and she has the 32 resistant force. So it's quite similar to what happened here, except let me just draw the picture again. Except this time the acceleration is 0. So that means this 32 the driving force here must also be 32. It must equal out. So that driving force that was in the power formula must equal 32. And we know the power, they said that's the same. So 280, this is power, is equal to force. We know it must be 32. The only thing we don't know is the velocity, and that's what they're asking us there. So velocity is 280 divided by 32, which, let's have a look, is 8.75 meters per second. So that's the answer to part B. In part C, they set up a new situation with the cyclist. They still have mass 80 kilos, but they're now coming down a hill. We know the length of the hill is 32.2. They give us an angle of the hill in a roundabout way. The sine of the angle is 1/20. They tell us she has a power output, so we can use that power to perhaps get a force if we want. They tell us a resistance force is acting against it. Although they don't tell us the force, they tell us the work done by that force is in a certain number of joules. Now the reason they've given it that way, finally they tell us it takes 3 seconds to get down this hill. I think the reason they've given us the resistant force, or the work done by the resistant force, they want us to think energy. Best way to do this question is going to be energy. We'll think of two situations where she's at the start of the hill and she's at the bottom of the hill. Another clue to why this is right is they give us the speed of the cyclist at the top of the hill, and they ask about the speed at the bottom of the hill. Remember, when we're dealing with energy, kinetic energy, it's really mass and speed. Potential energy, it's just the height, so they've given it measurements for that. Actually, let's fill in, let's make this a triangle. They've told us is 32.2, and they've given us an angle here. They haven't said. I'll just name it theta for now, so we can get a height and stuff. So really set this question up before I do the maths. I'm going to get the total energy of the cyclist at the start. That's her kinetic energy and her height. Then I'm going to get the kinetic energy. I'm going to get the total energy at the end. That's her kinetic energy. She has no height. She's at the bottom of the world. And I'm going to try put them equal to each other. But first I will add any energy she added in. That's the power she did. And I'll take away any energy that was taken away through the resistance force, the work done against it. So that's what we do. So let's what's the energy to start this system? Let's say start here. The energy is a half times her mass times her speed, which is 7.5 squared, plus her potential energy. That's her mass again, times her height. Her height is a sine of this, or 32.2 multiplied by sine of this angle, which they tell us is 1 over 20. That's her height times gravity, which is another 10. That's the energy to start. Put all that into a calculator, and let's see, we get 3,538 joules. That's how much energy was at the start of the system. At the end, a little shorter, that's a half 80 v squared. We don't know v, we're looking for v. Clean that up as much as we can, 40 v squared. Energy at the end of the system. Then we just put in equals here. We go 3,538 must equal 40 v squared. Once we add or take away a few things, the resistance was doing work against us. That's taking work out of the system. That was minus 1,128. Then what work was she adding in? She was doing power. That power being 120 watts. So how much work is that? We need to remember our formulas here. Power, work, how does that go together? Work is equal to power by time. By time. That's T. Yeah, that's it. We have the power. We have the time. The time's 4 seconds. So in this case, the work done was 120 times 4, which is 480. Equals 480. That's adding in 480 here. This we just add these together, or add or take them together, divide by 40, and we should get v squared is I'm just check my numbers there. We should get v squared is equal 72.25, or v is equal to 8.5 meters per second. And not really that long of a question, but this is part C now, 6 marks. But it was difficult. I'd say a lot of students would have forgotten this. Probably better to remember as power is equal to work over time would be a bit more of a famous way to see that. Anyway, if you have any questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a good day.